Hey there, Christopher.
How's it
Brandon.
going?
Good. What questions can I answer?
I don't really have any.
I don't as well. I'm just I was gonna start doing the homework and overhear any questions that were gonna come up.
Okay, sounds good. I'm going to pause recording. Oh, got a question. Give people a minute or two. Don't mind me as I eat. Hey, Mary, you have a question?
Oh, no, sorry. Or I mean, I do have a question, but if someone else does, they can go first.
Oh, go for
it. So I don't know if I have been trying to work this out wrong, but the conceptual question in chapter 9, it was the first conceptual question. It is asking if
this is from the homework?
Yeah, from the homework.
All right, hold on. Let me pull it up. What would happen there? Homework. Why do you keep giving me this homework? Oh, it's trying to do that. All right. This is chapter 9 homework?
Yeah.
Open a new window. Where's share screen? Okay, which conceptual question?
It was 9.2, so I think it's the second one.
Let me annotate. This one. Particle A has half the mass and 8 times the kinetic energy of particle B. What is the speed ratio of VA to VB?
We just solve for V in the kinetic energy equation, and then put A over B. I don't know.
So let me see. Let me just write this down so I can open up it. So we have particle A has half the mass, and A has 8 times the kinetic energy. Okay, so let me stop this share, open up a whiteboard. Okay, so I know that kinetic energy is 1/2 mv squared. And just so you know, this is people who are turning in this, where's this? Was homework problem 9.3, conceptual question 9.3. So what we're told is that, I just erased this, what was it? The mass of A was half the mass of B?
Yeah.
And that the kinetic energy of A was 8 times the kinetic energy of B, right?
Right.
And what we're looking for is what? VA over VB? Or the other way?
VA over VB, yeah.
Okay, so VA over VB equals what? Well, one, just from this equation for kinetic energy. If I were to solve this for speed, what I get is speed equals the square root of 2 times the kinetic energy divided by the mass. That's just me solving this equation for V. You good on that part?
Yeah.
So if I want VA over VB, that's going to be equal to the square root of 2 times the kinetic energy of A over the mass of A. divided by the square root of 2 times the kinetic energy of B divided by the mass of B.
Right.
So then if I simplify this, what I get is the square root of 2 kinetic energy of A over the mass of A, and then times the mass of B over 2 times the kinetic energy of B. Or just because dividing by a fraction is the same thing as multiplying by the reciprocal. So we good on this part so far?
Yeah. I mean, if this is how you go about it, I might have just done my algebra wrong, but I got it wrong twice, so.
Okay, so this was mb over 2 times the kinetic energy of B. So then the key here is I know, well, this was 8 times the kinetic energy of B. So then what I can do is replace for A 1/2 the mass of B for the mass of A, and the kinetic energy of A 8 times the kinetic energy of B. So here for kinetic energy of A, I'm going to have that is 8 times the kinetic energy of B. The mass of A is 1/2 the mass of B. And over here, I've got mass of B 2 times the kinetic energy of B. And then basically all you have to do is simplify. So the masses of B's cancel out, the masses of, or the kinetic energy of B cancel out, and you just end up basically with a number.
And isn't that number the square root of 2? Or the square root of 4, I mean?
So this is 16. So it's a square root of 16.
Okay.
Which
Because yeah, that makes sense. I used 0.5 instead of 1/2, and then I think I just did my math wrong. I should have multiplied by that 1/2.
got it.
Okay.
All right.
Thank you.
You are welcome. Let me stop this.
I'm gonna get going.
Okay. I'll be here for another 12 minutes. If you have any more questions, pop on back in.
All right, well, talk to you on Tuesday.
All right, take care, Christopher.
Is the only equation we have for the spring stuff F equals -k times displacement?
Yep.
Or dotted? Is it times or dotted with displacement?
It's times. And I'm going to cover that on tomorrow.
Right. So,
Thanks, Brendan.
Joe, I have a question on the PLC.
On what?
On the PLC.
Okay.
So I was only able to connect for about the last 5 minutes. I was having trouble with the Wi-Fi. And I just got the part where you talk about the PLC and about the work.
Yes.
And I kind of just want to double check to see if I'm understanding it. In
Okay.
part A of number 1 for the PLC.
Mm-hmm.
It's asking us to rank it in terms of gravity, right?
Work done by gravity, yes.
Okay. And so looking at the animations, I concluded that the only one that does the most work by gravity would be animation 3 because it has that parabola.
No. So if you tuned in late, one of the big things I went through is that gravity is what's called a conservative force. And that means a couple things. The important thing for this part, chapter 9, is that the work is path independent, which means it doesn't matter how I got from my initial position to my final position, the work done by gravity is always going to be the same. So if I pick up a box, it starts here and I end here. Gravity does a certain amount of work. And what I showed in lecture was that the work done by gravity is negative mg delta y. The key thing here is, as long as I start here and end here, gravity does the exact same amount of work and it doesn't depend upon the path taking. So if instead of taking this straightforward path, going straight up, I lift it up and I do some kind of weird curved path, when I go and I calculate the total work done, it's going to give me the exact same answer as if I lifted it straight from initial to final position.
Okay, and this is like you said during the lecture. The reason being is because the work of gravity is countered by the work of the agent doing the other force, right?
Say that beginning part again.
The work done by gravity is countered by the work done of the agent. In this case, in the PLC, the
Right.
hand pulling the bowling ball up.
Right, so the bowling ball, so the other big thing is the work done by all external forces is basically equal to the change in energy of the system.
Okay.
So right now, we're only really looking at kinetic energy because we haven't started looking at potential energy. So this would really be then the work done by gravity plus the work done by the agent is going to equal to the change in kinetic energy, which in this case is 0 because I forget what it was, a bowling ball or whatever, it starts from rest, ends at rest. So it's not changing its kinetic energy at all, which means the total work done by all forces has to be 0. So like in this problem, the work done by gravity is the same in all cases because they all start and stop at the same position. Even though they took different paths, they started at the same height, they ended at the same height. The work done by the agent has to just equal to the opposite of the work done by gravity. So if gravity is doing the same amount of work in all cases, that means the agent is also doing the same amount of work in all 4 cases also.
Oh. Okay, so like in the case where it's asking us the work done by the bowling ball by gravity, it's the same for all cases.
Correct.
And in that case, we won't have to list them from least greatest to greatest like it's asking us, since they're all equal to each other.
Yeah, you just say they're all equal.
Whoa. Okay. All right, that makes more sense.
Oh, good.
All right, thank you.
You're welcome. Let's see if we got a quote for question. All right, Mary, bye, Mary. Leo, Kenny, any questions from you? Or Leo just has any other questions? Or Kenny? Hey,
Can you
Kenny.
hear me now?
I can hear you now.
Okay, just trying to figure out how all this works.
Okay.
Looks like I got a lot of material to go through, so yeah, I'm bound to have questions later. Right now, it's just good to see your face.
Hey, good to see you. Well, I don't see your face, but you got, you were able to create an account on Mastering Physics and get all of that set up, and obviously you've got Zoom working, so now it's just a little bit of catch up.
Yeah, and everything I saw today doesn't look like it's that far over my head that I'm falling behind too much. So.
No, and we're about a week and a half behind or something. I'm gonna have to figure out how to catch up. I mean, it's unrealistic to assume we're gonna cover the exact same amount of material as if we didn't have this whole COVID-19 thing, but I still want to cover almost everything I can, so.
Definitely interesting times we live in.
Yeah, it's interesting is a good word for it. So.
Well, thanks for your efforts.
Yeah, you're welcome. And if in the process of catching up, stuff comes up, I'm pretty much checking email every day. So send me an email or come to office hours or something like that, and I can help you figure it all out.
Okay, sounds good.
All righty.
Thanks.
Yep, I'm gonna be here for another 5 minutes. So if anything else comes up, you know where to find me.
Actually, I had an idea.
Okay.
I don't know how sound it is. When you signed off and logged off, and there's like 40 some odd people still in the class,
Yes.
would it be possible for us all just to have like a few minutes of chat while you're breaking?
Oh. You
Yeah,
know what? I
like
could
little.
do that. So rather than, I guess I could just cut the video too. So I was doing it to like sort of stop it so that I could just open it again as office hours, just because Zoom records all the meetings. But I do lose a lot of people. So what I could just do is say I'm taking a few-minute break to use the bathroom. I'll turn off my video, and then yeah, give people a chance to chat.
That might help on the connectivity of the classroom.
Right. No, I like that idea. I will try that out tomorrow.
Okay.
Yeah, and I'm always open to other ideas. So I have to figure out
Yes.
now how to do the finals and celebrations, since we're not going to campus for the foreseeable future.
That's yeah. That
Yeah.
could be a challenge. I was thinking, we got these big parking lots. You could just have everybody park in a separate space, every other space.
I thought about getting creative like that, but the problem is with this whole shelter at home thing is that, like I've got my daughter half time, and so she's not in school. And so I'm trying to work around my schedule and her schedule. Everybody's schedule is so crazy right now that I don't think you can really require people to show up somewhere at a given time these days.
Oh no, and undoubtedly before this is over, there's going to be more restrictions on people's movements. So.
Oh yeah, it's yeah, we haven't seen the end of it yet. And yeah, I will end up probably having to curve the class. Like, people did pretty good on the first quiz, and the quizzes will probably continue to be multiple choice, as may be the celebrations, because I can't really conceive of a way of doing the celebration the way we did the last one, where I'm going to have people take pictures of 10 pages of problems and then email them to me and try and grade them online. I just don't see how that could work. So still working on it, but we'll see.
Yeah, I'll noodle it.
Yeah. If there's no other questions, I'm going to end this office hours. Leo, any other questions from you?
No, it's all good right now.
All right. Anything from you, Kenny?
Nope. Have a good
All
day.
right. Well, I will then hopefully see you guys on Tuesday, tomorrow.
All right, see you.
All right. Take care. Have a good rest of the day.